I'm Ava.
And I'm Beth.
This is Calculus AB.
Are you ready to graph this function? I am. Derivatives, which are the instantaneous rate of change or the slope of a tangent line. F prime of x is the same thing as dy dx, which is the same thing as the derivative of f of x.
The first definition of a derivative is f prime of a equals the limit as x goes to a of f of x minus f of a over x minus a. I drew a little graph here using points a and x, and I connected the two, and I drew the curve of the secant line and the tangent line at a. And as you see, as x approaches a, which is the same thing as the limit, you have the tangent line. So as x gets closer to a, you're just left with the tangent line, and taking the slope of that will give you the derivative.
Now, we have an example. F of x equals x squared plus 2x plus 1. Write a limit that represents f prime of 2. Then you write an equation of the tangent line at x equals 2. So the first thing you do is you plug in 2 into f of x, and you get 9. Then use the limit equation in definition 1, and you have limit as x approaches a, f of x minus f of 2, x minus a. And this eventually simplifies down to x squared plus 2x minus 8. And to simplify this further, you can factor, so you get x plus 4, x minus 2 divided by x minus 2. You still keep the limit notation here, and x minus 2 cancels out because it's in the denominator and numerator. So you just get the limit as x approaches 2, x plus 4. You plug in 2 for x, and the answer is 6. Now we're given the point x equals 2. We plugged it into the equation, we got 9. So that's our point, and then we use point slope, so we get y minus 9 equals 6, x minus 2. That's the equation of the tangent line.
Definition 2 of the derivative is similar but different. It is f prime of a equals the limit as h goes to 0 of f of a plus h minus f of a over h. And what I wrote out here, I wrote the slope of a secant line using this would just be kind of like y1 minus y over x1 minus x. But in this case, the y's and the x's are kind of weird. And then I wrote the slope of the tangent line, which is what I already said above. It's just the limit of the secant line, which becomes a tangent line. And once again, I drew it graphically so you can see we have these two x values, a and a plus h. And as h, which is the distance between them, as h gets smaller, as it approaches 0, as it says above in the limit, then we're going to be left with the slope of the tangent line, which is the derivative. So here the problem is asking to use this second definition that you just learned to find f prime of 7 when f of x equals root x. So what we have the equation for f of x, and we have the point 7. 7 equals x, or in this case a sort of represents x. So we can plug in 7 for a in all the places in the equation. It becomes f of 7 plus h minus f of 7 over h. So we can find f of 7, we just plug it in into f of x, so we get root 7. And then f of 7 plus h, that's sort of saying, okay, put 7 plus h in for x in the equation, so it becomes root 7 plus h minus root 7 over h. We've talked about this in a previous video about limits, you need to use a conjugate pair, because if you plugged in 0 now, you would get an undefined line. So you need to multiply by root 7 plus h plus root 7 on the top and bottom. And once you do this, it simplifies and 7s cancel out and the h cancels out the h on the bottom. So you're left with 1 over root 7 plus h plus root 7. Now you can plug in 0 for h and get the limit, which simplifies to 1 over 2 root 7. And that is your derivative. So f prime of 7 equals 1 over 2 root 7. The next part of this question is to write the equation of the line tangent to the curve at x equals 7, or basically it wants you to write the equation of the tangent line. It's basically like writing the equation of any line. We're going to use the point slope formula, which hopefully you know, but if you don't, it's y1 minus y equals m times x1 minus x. And we already have an x and a y. We have the 7 and the root 7 we got from plugging it into f of x. And then we have the slope of the tangent, which we took when we got the derivative, f prime of 7. So the slope is 1 over 2 root 7, and then we just plug it in. Y minus root 7 equals 1 over 2 root 7 times x minus 7, and that simplifies. If you want to simplify it, it's up to you. And that is the equation of the tangent line at x equals 7.
The limit as x approaches to 3 to the x power minus 9 divided by x minus 2. So what is f of x? Since x approaches a value that is not 0, we know that it's definition 1. By using definition 1, we know that f of x equals 3 to the x power because it's given in the equation. We know a is 2 because x approaches 2, and in the definition 1, x approaches a. For the second problem, it is definition 2 because we have an h. Due to the equation in definition 2, we know that the a is equal to 4 because 4 plus h squared is part of the limit. And we know the f of x is x squared because the a plus h, the 4 plus, is squared. So that's how you determine the f of x and a for these two definitions.
Okay, so for this next problem, we have the equation f of x equals x squared plus 3x. And in this case, we're just going to determine a general f prime of x equation. So rather than finding the derivative at a specific x value, we're just finding a general derivative equation that we can plug any x value into. So I'm using the second definition with the limit as h goes to 0, blah, blah, blah. So instead of plugging in a specific x value for a, we're just plugging in x for a. It's kind of more work because we have to plug in the x plus h part into each x value in the equation. So we have x plus h squared and then plus 3 times x plus h to account for the 3x, and then minus x squared plus 3x, which is just the equation over h. Well, you can't just plug in 0 here because then there'd be a 0 on the bottom, which is not good. So instead, we have to expand in this case. I squared that x plus h, and I distributed out the 3. So then you can start canceling things out. The x squared cancels out because there's an x squared and a negative x squared, and then the 3x and negative 3x cancel out. And then you're left with h squared plus 2xh plus 3h over h. And there's an h everywhere, so you can factor out the h. So then it becomes h times h plus 2x plus 3. And then that h that you took out will get rid of the h in the denominator, which is kind of what you always want to go for. You get rid of the h in the bottom. And then we're left with the limit as h goes to 0 of h plus 2x plus 3. And then you can plug in 0 for h, so we're just left with 2x plus 3 as our y prime equation.